my presentation for today is all about the three types of machine learning, which are supervised, unsupervised, and reinforcement learning. So first, let's tackle about the machine learning. So it provides the machine the ability to learn automatically and improve from experience without being explicitly programmed. So as you can see here, when we were once a child, we look at the same fruits like cherries, apples, and oranges, and we tend to say, oh, they look the same. But as time passed by, we saw a lot of fruits like that, like cherries, apples, and oranges. And then eventually we can distinguish and determine what are those. So same as for the machine learning. So we are going to teach machine using data. We're going to feed it into the machine, and for those historical data, if the machine see it over and over again, it can also determine what are cherries, what are apple, and oranges. And the more data we feed the machine, the more accurate the results will be. So the question is, do all ML systems learn the same way? So as we can see here, we have supervised, unsupervised, and reinforcement learning, and they all learn differently. So the answer is not quite. So let's first talk about the supervised learning. So the keyword for this is the labeled data. So it teaches the machine with labeled data. So as you can see over here, we do have labeled data, which is an image of a cat, and it has the label cat. So when the machine sees this image, so it can distinguish that it is a cat because we labeled it as a cat. So same goes for the dog. Okay, and then the examples that I can share with you is the bank loan approval based on your credit card statements, and playing golf outside based on the weather forecast, and also the famous example of supervised machine learning is spam filtering in our email. The next one is the unsupervised learning. So from the word itself, unsupervised, so we don't give any guidance to it. The machine is trained on unlabeled data. So it is the same as the example a while ago, which is the supervised, but the difference is we don't have the label. We don't have the information prior to the training. So what it does, it uses association and clustering for it to group the same categories. So examples are audience segmentation. So from the photo, we can determine that our audience can be women, men, also it can be children or adult. And for the movies, there are also recommendations which Netflix used for them to improve their sales. And in the first place, we don't know that there is an, an underlying relationship between these items such as bread and butter, cinema tickets and popcorn, and the beer and diaper theory. Have you heard about it? So using the market basket analysis and the historical transactions from grocery stores, there's an insight and business decisions gathered that there are more transactions that has bread and meat usually has butter in it. So as the cinema and popcorn and the bread and the beer and diaper. Next is the reinforcement learning. So it learns by trial and error with rewards and punishments. So you don't need to have predefined data, just the experience, the trial and error of the agent. So for example, there's a machine over here, the maze over here, and there's an action. So if its action is positive, you will have reward, but if not, you will lose points or you will have punishment. So the examples of this are AlphaGo Zero, which is developed by DeepMind by Google, and also the AI chess player and Rubik's Cube solver, and then the king of reinforcement learning, which is the self-driving cars. So for the problem types, where can we use each type of machine learning is For the supervised learning, we can use it in regression and classification problems. For unsupervised, it's for association and clustering problems. And for reinforcement learning, it's for games, AI, robotics, and so on. So lastly, the three core types of machine learning I can say is are the supervised, unsupervised, and the reinforcement learning. So it's important for us to know more about this because it is the foundation of machine learning systems and it influences how we teach our students and how we do our research and also to allow them to deploy real world AI projects.